rather than just, what the hell?
You could do it, Mr.
Select your nickname.
Rather than just find the interval, the radius of convergence, I'm actually going to go all the way and find the interval of convergence and complete endpoint tests, just so we have extra practice at that. Of course, that presupposes that an endpoint test is appropriate. So for question 1, an endpoint test would be appropriate. We have this right over here, with n plus 1, n plus 2 over 4 to the n power, and then we have x minus pi to the n. So the first part of the solution here is to realize that this is not geometric. And that should be pretty easy to see. So we're going to apply the ratio test. And I'm writing the word ratio test because I expect you to write the word ratio test as well. Okay. So we're going to take the limit as n approaches infinity and change all the n's to n plus 1. Okay, n plus 1 is n plus 2. N plus 2 plus 1 is n plus 3. This is x minus pi to the n plus 1. Whole thing over 4 to the n plus 1 times n plus 1, n plus 2, x minus pi to the n, 4 to the n power, and force that to be less than 1. And man, is this ratio test annoying.
But lots of stuff cancels. A lot of stuff cancels.
Oh, you like it when things cancel out.
Do you not?
Alright, so the absolute value of x minus pi, that comes out. The 4 comes out. Limit as n approaches infinity. Let's see. N plus 1 cancels out. N plus 2 cancels out. So we're just left with n plus 3.
Yeah.
Over n.
So.
Okay, let's take a limit here. N plus 3 over n. This limit is 1. So what we get is x minus pi, absolute value, over 4, is less than 1. Or, to rearrange that, the absolute value of x minus pi should be less than 4. So this is the end of the problem because now you can read center and radius. Center, radius. So radius equals 4. Again, we're going to continue the problem because it never hurts to have more practice here. So we're going to check our endpoints here. So we're going to check, what is that, pi minus 4? Center minus radius, yeah. And that should be x equals. So my series is n plus n, n plus 1, n plus 2, pi minus 4 minus pi to the n, the whole thing over 4 to the n. Checking the endpoints.
We're adding it.
That simplifies to, what is that, n cubed plus 3n squared plus 2n over 4 to the n times negative 4 to the n. All right, let's keep going here. We have negative 1 to the n.
N cubed plus 3n squared plus 2n.
N cubed plus 3n squared plus 2n over 4n times 4 to the n. Great. That means we have negative 1 to the n cubed plus 3n squared plus 2n, and then this is the part where we have to analyze. Okay. So analysis, alternating series. Great. Alternating series.
But if it tells you to just find the values of convergence, you don't do the endpoint test, right?
That's why I'm doing this in green. Alternating series, we're going to take the limit as n approaches infinity of n cubed plus 3n squared plus 2n. That limit is infinity. Doesn't really matter what it is, as long as it's not 0, series diverges.
At n equals.
At x equals pi minus 4. Yeah. When you're doing an alternating series test, if you get anything other than 0, the series diverges. Okay, let's check endpoint number 2. We're going to check x equals pi plus 4. Sorry, I'm going to slow down a little bit. This is a good tasting. Who made this? Don't you know their names by now?
Would you like us to make up the name?
No. These are people. They're just messing around with you. All right, checking the second endpoint, we start with the series, what is that? N plus 1, n plus 2, and now we get x minus pi minus 4.
No. Pi plus 4.
Pi plus 4.
Minus pi.
Minus pi plus 4.
Just erase it out. Pi plus 4.
Pi plus 4 minus pi to the n power, whole thing on top of 4 to the n.
Yes.
Which simplifies into
3n.
n. 3n cubed plus 2n squared plus 2n. Sorry, 3n squared.
And then just n cubed.
Wait,
Over 4 to the n times 4 to the n. Which simplifies to n cubed plus 3n squared plus 2n.
The radius of convergence.
And I take a look at that series and I notice that,
It's the n.
yeah, the series, individual terms do not
alternate.
get closer to 0.
That too.
In other words, we can use an nth term test to show divergence. Nth term test for divergence. Okay, so the limit as n approaches infinity of n cubed plus 3n squared plus 2n is equal to infinity, which is not 0.
What's those rules? Okay, wait. So like, if it's anything over infinity is 0.
I have to remember all these tests.
If it's a constant over infinity is 0. If it's infinity over a constant.
Infinity.
Infinity, and then it hits. What is it? 1. Yeah. Is it ever 1?
It is if the lead terms simplify to 1.
But like, if you get zero, then
Oh, like it's like
Yeah.
if you
You only do it if you know it's going to diverge.
Yeah.
Like the limit is n
So-
approaches of n has n approaches.
how do you know when to do that Endpoints test?
If you suspect divergence.
Jennifer Avila, if you're in campus, please come to the main office. Jennifer Avila, if you're in campus, please come to the main office.
Yeah. Nth term test, remember, never so remember, the nth term test never shows convergence. It only shows divergence. The only time you should be using the nth term test is if you suspect divergence.
Oh, you suspect convergence.
You would not use the nth term test.
So it's divergent at x equals 5.
Okay, so interval of convergence. X must be between pi minus 4 and pi plus 4. That kind of takes care of that. I mean, that's above and beyond number 1. Question 2.
The sum, natural log of x to b. What's this holding on the shift?
Straight line. 90 degree, I think 45 degree angles. Okay, interval of convergence.
Natural log of x to the n.
Okay. Series has an x, so it's a power series. The only n appears as a exponent, so this is geometric. If you're not sure, you want to write that out. Okay, so that tells me that I have a geometric series. So I'm going to write the word geometric series. In fact, I'm going to write the word geometric power series just to be fancy. And the ratio equals natural log of x.
First term equals 1.
No, we don't know what the first term is. Oh, yeah, sorry.
What? Yeah, what? Wait, why were you saying that we didn't?
Saying that we don't know what the center is.
So 1 over
This part, do we have to write what tests are we using?
Yes.
oh, okay.
All right, so
What-
waiting for you guys to finish up here. Were you good to continue? Okay, so the absolute value of the ratio needs to be less than 1. Sorry, the limit, no.
No, it's not.
Absolute value of the ratio has to be less than 1 for convergence.
Yes.
Now, a note about solving this. This is not simple polynomial work anymore. So, using polynomial methods to solve this, probably not a good idea. What you can do is you can say the natural log of x should be between 1 and negative 1. Like this. And then you're going to exponentiate. E to the negative 1 should be less than the natural log of x, should be less than e to the first power, sorry. And that tells you that the natural log of x should be between 1 over e and e. So somewhere between 1/3 and 2.7.
2.7, 18, 28, 18, 28, 45. I remembered it, Mr. Ferrer, yeah.
Sophia's reading.
I wasn't looking.
Stop cheating. Do I need to test the endpoints?
Yes. No.
No.
No, because geometric.
Geometric, no endpoint test.
Because it's geometric, Sarah.
Geometric series, no need to use no need to check the endpoints. Question 3, find the interval of convergence. We have x squared minus 4.
21 to the end. Yeah, geometric.
This entire thing raised to the n power. This looks pretty good for a geometric series because the only n is the exponent. But if you're not sure, write it out. And n equals 0, we get 1. N equals 1, we get
X squared minus 4 over 21.
n equals 2, we get n equals 3, we get okay. Thank you. And that should be enough to tell me that this is a geometric series.
The absolute value of x is less than 5.
Where the first term is 1 and the ratio is x squared minus 4 over 21. Great. So for convergence, the ratio x squared minus 4 over 21 should be less than 1. X squared minus 4
Less than 25.
should be less than 21.
X squared is less than 25.
Abs-
No absolute value, right? And then you put the absolute value and take the square root. You technically keep it there. But all the other times you don't have it.
We have x squared minus 4 should be between 21.
Wait, doesn't that still need the absolute values? Because. Doesn't no, yeah, no, I understand.
All right.
Technically, that could, if x is 1, then it could still be negative. But he did it the other, he added it with it. Yeah. Yeah. It's 5.
Okay. Oh, that's pizza time. Hello.
Oh, yeah.
Yeah, I'm sending someone to the front of the school.
Bye, Sarah.
Front door, yes.
Where do you order the pizza from?
Papa John. Right, everyone, let's continue this, please. We need to add 4 to everything.
This is not turning out. Right.
This is not, yeah.
Just do it the other way.
Whoa! What was that?
Sticker sent.
We're getting a call from headquarters.
So why don't you just move the
But it's easier doing it just x squared.
Yeah, no, it
But then at that point you don't need the absolute value because anything squared is positive. Yes. And now it's the absolute value of x is less than 5.
Why is that allowed?
I don't know. We mix it.
Because the absolute value is always already greater than 1.
Wait. What? Is it
If
negative?
you have a negative number,
Sorry?
it's not like we're not.
Yes, when you ask it.
No, I get it. You get it? Yeah.
Okay.
Number.
Geometric series, so x should be between -5 and 5. Do I need to test the endpoints?
Do you prefer us to write it like that, or like the X is like the little E thing, and then
I prefer this.
Oh, you do? I think
you prefer the second one or the first one?
Second one.
Oh, okay. I was using the second one.
I did it first.
Okay, it's getting really difficult for me to even hear myself think right now. Question 3. That was question 3. Question 4. Oh my gosh, we're almost halfway done. Okay, so does this converge or does this diverge?
Oh, I can read it. N cubed plus 8
No.
is 6 to the N.
No, it goes to 1.
Let's see what it does.
This should converge.
It does.
Why? Oh, because.
Well, the denominator
Yeah.
grows much faster than the numerator.
Yeah.
So when it's faster than the numerator, it converges.
Not just faster, much faster than the numerator. Should converge. That's the easy way of doing this one. I mean, if you're on a multiple choice test, your denominator is a exponential function. Your numerator is a polynomial function. Exponential functions always grow faster than polynomial functions. And they usually grow much faster than a polynomial function. No, they will grow faster than a polynomial function. So the quick way to do this is to say, yeah, it converges. Okay? The other way to do this is to, let's see. We can use a ratio test on this. So we can use a ratio test.
Wait, it diverges if it grows a lot faster?
No. If the denominator goes a lot faster, it converges.
So ratio test, we have the limit.
Wait, are they the same
You didn't believe that our name was Richard.
Now there's like garlic sauce.
Okay. And again, this is not the power series variety, so you don't force it less than 1. You're just trying to see what this limit is. Thank you.
That's not what you're saying.
New management.
Oh, that's why. Is that what it says?
That might be why it was different.
Yeah. He was like, what's your, do you have the card?
We were like, no.
He was like, we
oh,
can guess
good.
the last word. That's
Okay, let's do this. Limit as n approaches infinity. Let's see, the 6 and a 6 over n. That gives me a 1/6. Okay, I don't remember how to cube this. This was that n cubed plus 1,331, right?
I don't know.
3n squared plus 3n plus 9 over n cubed plus 8. This limit here is
Uno.
1. So the limit is 1/6. Hey, 1/6 is less than 1.
When you say that it's 1/6, do you want us to say that it's because of the leading coefficient test, or can we just write it?
You can just write it. Okay? Yeah.
So when it's not a power series, you make it less than 1 after you finish finding the limit.
Is that how
If
it
it is a power series, you make it less than 1.
If you have a series that is not a power series, you compute the limit. Then you compare the limit to 1.
Oh, okay.
If the limit's less than 1, then the series converges.
Is that all for number 4?
That's it. Number 5. Number 5 and then pizza time.
Almost.
Number 5, we're taking a look at convergence or divergence for
Sum of n cubed over 3 to the n.
Again, you have a polynomial on top of an exponential function. This should converge.
That's what it says on the answer sheet.
But if you're unsure, and I could, if I was new to this, I probably wouldn't take a chance, and I'd probably use a ratio test. So let's use a ratio test. And we're going to take the limit as n approaches infinity of n plus 1 cubed over 3 to the n plus 1 multiplied by 3 to the n over n cubed. These are going to proceed a lot like the last one we just did. 1/3 on the outside.
1/3 is less than 1.
Limit as n approaches infinity of
Same thing as before. N cubed plus
n cubed plus 3n plus
squared.
3n squared plus 1
No, the first one's squared, the second one's normal.
over
As it would be 6n squared.
n cubed.
That's good.
Okay? Lead coefficients. N cubed over n cubed simplifies to 1. So the limit is 1/3. Less than 1. Convergence. Okay?
So,
And that's it for question 5. Pizza time.
You want?
Wow, Laura just cut everyone, you know? Laura, you're not
what?
Laura's cut.
Yeah, no, I know that, but I know
Does this zipper make a difference when you're taking it off? Because it doesn't go very far. It's like straight, like
There's also
this is for luck. Just for luck.
And the way they phrase this,
Any other cheese?
Cheese, queso.
7, 8. Hang on.
I thought there should be space.
Queso.
Here, if you.
Barbecue chicken. 1, 2, 3, 4, 5, 6, 7. There's one more piece of barbecue chicken. The other one's cheese.
What happened?
They botched it.
Yeah, no.
Try again. Cheese. Cheese.
Where'd the dollar come
Okay,
from?
so you were saying
I think if you put it in the thing that
the one I was confused. Okay, so yeah,
If you excuse the interruption, we'll extending the radar. If you are on campus, please come down to the main office. Extending the radar. If you are on campus, please come down to the main office as soon as possible. Thank you.
but not like yeah, that's how you get it. How do you know it's less than what it's pi?
Cheese, seconds.
Yes, this.
Cheese, seconds.
Oh my god.
Seconds, cheese.
I call one.
I called one.
Marty, Laura.
You say it's pi minus 3. After you get oh wait, can we get
Four, five, five.
One more cheese.
Five.
yeah, because you want it to be. I already got you. Okay, well.
Oh, really? Yes. Did you pay for it too? What?
Oh no.
One more cheese.
Dude, like, grab for him. One more cheese. Oh yeah, I know. No, I didn't have this problem. Hey Sophie, you ready for the Casey tomorrow?
I'm really nervous though.
You're gonna pass? Sophie, darling.
What are we doing?
I suck at English. I suck. Okay, that was one of our. But you're gonna take like, if you fail. Oh, I thought you were arguing. And you're like, can I just die? You're so smart. Because she always like. Actually, don't know what I always say. She's like, I know I'm not. Wednesday. Yeah, they never told us what we got on this.
Yeah, they did. I got mine.
When you go to counseling office, they come look it up for you and tell you. I think I passed too. On the math section, and instead of getting 100%, I go 1 point off. Sarah, I'm pretty sure you didn't pass. Pretty sure you had to think I might have failed.
I got the
Sarah, I got 1 point
same.
off. You're taking it again tomorrow? Yeah. Are you?
5 or 6 retakes.
There's probably one for
Sarah.
2 times.
So I passed the piece. I'm pretty sure like my 5-year-old brother can pass. He was so stupid. Especially the one where it's like, no, but they want everyone to pass. But
Wait, really?
yeah, that was
Oh, like the group ones.
yeah. You know how they give you like a document or something, like answer questions about it. Like one of the dotted lines. No, I really very serious. I forgot. Yeah, a lot of the questions are ridiculous. But when I read the questions, I mean, seriously, this is like for elementary.
So you try to be able to get over
Like, I still don't know why I like when the math section is like no! I tried to jump in the water! No, I got one kind of wasted. See, it doesn't matter on the grades. And what you get as long as you pass. Yeah. I know. No, but I was trying to be like, I didn't think of all my time. Oh, God! That's what she expected them to get it's like the CSTs. Oh, yeah. Remember the so ugly. What's that? Yeah. Oh my god. Wait, why is it oh my god.
We used to be smart. Probably don't want to do that. Yeah. Sorry.
probably won't go into it. It never does.
We have a lot to do though. Or actually we don't.
I still don't know how to do it. We only have 5. We should ask
So Ferrario, could you do number 11 again? The one with 9 turns or 8 turns? Because I still don't know how to do it.
The way we did in class, he doesn't know which is right thing. He said what we did in class.
We're not gonna have it right on the test.
That's not what I said.
No, but are we? I'm asking.
Possible.
Are we expected to know how to do it?
I waited for
Okay, everyone, we're gonna get started again. Okay, so for question 6, we're supposed to use a limit comparison test, which means we need to compare it to a series which is similar, hopefully a p-series. So we got to find the closest p-series to this. What is the closest p-series to 4n over n squared plus 3?
N squared.
And the best way to do this is to take this general term and then to start, well, first of all, take out all the constants. So we're going to compare to is series 1 over n, which, by the way, diverges.
The only time we do endpoint tests is for ratio tests, right?
Take a limit as n approaches infinity of 4n squared over n squared plus 3.
Why is it 4n squared?
4n over n squared plus 3 times n over 1, which is a reciprocal of the series I'm comparing it to. Should I write it the other way?
Of the division.
No, we're good.
With the division divided by
I don't know, that's how we
1 over
usually do
n.
it, isn't it?
That's how I do it. It doesn't really make a difference, right? It doesn't know at this point. Just like
Okay. Let's go ahead and compute this. This is a limit as n approaches infinity of 4n squared over n squared plus 3,
So what you wrote before.
which is 4. Which is a number. As long as I get a number, the limit comparison test says the two series will do the same thing. Okay. Since 1 over n diverges, 4n over n squared plus 3 diverges.
If it's a constant,
Yes. LCT.
if it was like infinity.
If it's infinity, then you can only show divergence.
So if it's 0.
Yes, if it's 0, you can only show convergence. If you get 0, you can only show convergence. If you get infinity, you can only show divergence. Ted.
So if you're comparing it to a series that diverges, if your limit comparison test converges to a number, then you prove that it diverges. But what if like you were comparing it to a series that diverges, and your limit comparison test said it diverges, like it went to infinity?
Okay, if like I was trying to say before, if you're comparing to a diverging series, and you get infinity, then you've proven divergence for both series. If you're comparing to a diverging series and you got 0, then your test is inconclusive.
And anything other than 0 proves that it diverges?
But if you're comparing it to a converging or infinity, the opposite.
Yeah. If you're comparing to a converging series, if you get 0, then you've proved convergence. If you get another constant, you've also proved convergence. But if you get infinity, then the test is inconclusive. Okay? Let's get to the next one. This one is not quite as obvious. And in order for us to figure this out, I'd actually like to take out the calculator. You don't have to take out the calculator. I'm going to take out the calculator. And I'm going to look at two functions. I'm going to look at the first one I'm going to look at is y equals x. The second one I'm going to look at is y equals the natural log of x. I'm going to set a pretty big window here. I'm going to go from 0 to 100, and then 0 to, let's just try 1,000. No, 100's fine. Actually, let's go to 1,000. And let's take a look.
It's right in that little box thing.
There's y equals x. There's the natural log of x. Oh, wow. Okay, which one's faster? Y equals x, yeah. Okay. In other words, x is always bigger than the natural log of x. Okay, so let's write that result here. The natural log of, x is always bigger than the natural log of x. And that's going to help us figure out number 7.
Right,
Highlighter doesn't erase. Bless you. Okay, so that helps me. N is always bigger than the natural log of n. let's get a sense of this. Do you think that the denominator grows fast enough for convergence? I think so.
Yes.
I believe the denominator grows fast enough for convergence. Notice that we're multiplying by n here, and we're multiplying by natural log of n squared. Okay. So that kind of tells me the power in the denominator is definitely greater than, oh my god, definitely greater than the first degree, which is kind of like the dividing line between series that converge and series that do not converge. Okay, so I'm going to compare this to, yeah, let's compare. Okay, so let's do this comparison here. We're starting with 5 over 2 plus 7n natural log of n squared. And then we're going to take all those constants and we're going to get rid of them. Okay. This right here is not a p-series. But if I replace all those natural log of n's with n, I do get a p-series.
You just basically keep replacing stuff until
Remember, my goal here is to get a p-series. I can't have a p-series with a natural log of n. I changed it to an n. Notice I'm not saying they're equal to each other. By the way, this is actually really important for you. Nowhere did I write that all the three of these things are equal to each other, right?
You put arrows.
Mathematically, I haven't written anything untrue, which is something that I hear that drives them crazy at the AP reading, is if someone wrote down this equals this equals this equals this, that's mathematically untrue and it kind of leaves a bad taste in your mouth. So if you don't mean equal, don't write equal, basically. Okay, so we're going to compare these two. We should probably figure out if this converges or diverges. 1 over n cubed converges. P equals 3. So let's go ahead and do this one. We're going to take a limit as n approaches infinity of 5 over 2 plus 7n natural log of n squared times n cubed over 1.
That's gross.
Yeah, this is not a fun thing to do. Limit as n approaches infinity of 5n cubed over 2 plus 7n natural log of n squared. Actually, I don't need those absolute values anymore. N's going to infinity. All right, how can I figure out this limit? Infinity over infinity. Yep, L'Hopital. All of our terms are positive. N's always positive. We're going to infinity. All right, let's use L'Hopital's rule. That's equal to the limit as n approaches infinity. 15n squared over product rule. What's the derivative of 7n? Good. 7 natural log of n squared plus 7n. What's the derivative of natural log of something squared?
2.
2 times the something times the derivative of the something. What's the derivative of the something?
1 over
1 over n? Ew.
Why are you doing this?
Let's simplify that. I'm going to multiply the top and the bottom by n.
With the n's cancel out. With the 7n and the 1 over n. You don't have to multiply.
No, you don't.
It's plus the 7. It's 7n times 2 times natural log of n
Oh.
times 1 over n.
Oh, that one.
That n.
That n.
Not the natural log of n.
This and this can cancel.
Yes.
Okay, so that's equal to 15n squared on top of an ugly expression. 7 times the natural log of n squared plus 14 times the natural log of n.
Isn't 14n?
No.
Because we just canceled.
Oh,
Great. Oh, hey, it's still infinity over infinity. L'Hopital's rule. Limit as n approaches infinity of 30n on top of 14 natural log of n times 1 over n plus 14 times 1 over n.
Why do you have to not? Should it just be 1 over n? Because you don't have to chain rule 14 natural log n, right? Oh, my bad.
Great. I think we can, now we have to multiply everything by n?
Yeah. Duh.
What is that, 30n squared?
It's still infinity over 30. 30. 0. Never know what over n.
I just said that.
That's still infinity over infinity.
That's still infinity over infinity.
Why are you doing this to us?
I'm done with this problem.
There is a time. I would do that right now. No, now they're gonna think that we're lazy.
But you already know that it's.
Do you know how many more times we're gonna have to L'Hopital it?
This is it.
Infinity.
60n, 14 over n. Now I'm really worried.
You can just cancel this.
No, it's 60 over 14n squared. Which is about 30
What's 60 over
7.
14n squared?
No.
A 60n squared over 14.
I said 60 over 14n squared. Oh, I was making it a coefficient as a fraction. I knew
Which
that.
is infinite, right?
Are you being serious?
That was what I was thinking.
Yeah, it's an infinity or just diagonal.
Wait, no.
What did we do wrong?
We compared it to a converging series.
So it's inconclusive.
So it actually is inconclusive.
Oh, are you kidding me?
I'm sorry.
Wait, who made this question?
All right, so
This is why I circled this one.
let's see. Yeah,
I'm kind of confused because
guys.
in number 6 we got sum 1 over n and we said that it diverges. But in this one we have sum of 1 over n cubed and it converges.
Yes.
Why though?
If t is less than or equal to 1, it diverges.
Oh yeah, right.
So where did we go wrong here?
Everywhere.
I don't think
Are you allowed to multiply it by n over n? I don't get that
If
part.
you, Mr. Ferrer, if you didn't multiply it by n over n, wouldn't you have gotten 30 on in the numerator, and then you would have still had to, you still would have had the natural log situation, and then you would have kept on deriving it until eventually the numerator was 0, right?
No.
No, it wouldn't have worked like that because the fractions are still there.
When you get infinity over infinity, you
That's the
only
only
row.
zero. Wait, can I write those?
Hang on, everybody. I mean, we should look for something. Figure out what's going on with this.
Yeah, just use a different piece. No. Isn't it easier to just use like whatever n squared or something? I don't know.
So that we can
Wait, can I copy and wait?
But then we didn't prove anything.
7 says a convergence.
So I have
Yeah.
Mm-hmm.
It's okay if it's inconclusive, but then we didn't answer the question whether it diverges or converges. Because the function still diverges or converges, we just didn't get an answer from this test.
So why does it say that it does converge
Because we looked at the answer.
It doesn't say it converges Oh, I think I know where it's going. Here, look.
What went wrong?
This part that is like 7 times 2 times natural log of n. How does that turn over like 4 to the natural log of n? Like I saw n and n is the same variable.
N cancels with N.
That's natural log of n.
No, it's not. No, the natural log of N is just
Why does
natural log of N.
this become, why do you multiply by another 1 over n?
Because of the chain rule. 2 times 7 times natural log times the derivative of natural log. Okay, here's what I'm going to do. I hate not making progress on this, so let's put this on the back burner for a few minutes and let's figure out what's going on, okay? Let's do that. Okay, move on to the next question. Number 8. Okay, so this is a bunch, these are a bunch of interval of convergence questions.
So ratio test.
So possibly ratio test, not always ratio test.
Number 10. I don't think
X minus 9 to the nth power over 6 plus 2n. So we can see this is not a geometric series. If you can't, you want to write out the first few terms. 1/6 plus x minus 9 over 8 plus x minus 9 squared over 10
Okay, it's not geometric.
plus x minus 9 cubed over 12. This isn't geometric. So we're going to have to use a ratio test. Here's our ratio test. We're going to take the limit as n approaches infinity. That's x minus 9 to the n plus 1 over 6 plus. Now I'm going to be very careful here because algebra fail is real. 2 times a quantity n plus 1. Algebra fail is a real thing. This is a power series, so I'm going to force it to be less than 1. Okay. X minus 9 comes out.
6 plus 2n over 8 plus 2n.
Hello, serious.
Hi.
I filled this all out for you. Talk it over with the boss tonight.
Okay.
It's going to be first come, first serve, and it's going to go really fast because they're paying for our rooms. You get a per diem. They're paying for our miles. It's in wine country. And you get your own room, so if you want to bring said boss, that's not a problem.
I can always cancel.
But they're going to be pissed because they're trying to get 30 of us to go.
Yeah.
So, if you decide yes, fill out the remaining blanks, like your employee number, and sign, and bring it to Tapper. Cool? That would be nice. That would be fun. Look at all the big brain children.
I know. Okay.
Bye, nerds.
Moving on. This has got to be less than 1. This limit here, take a look at the lead terms. Ooh, tricky. The lead term is the second term.
Yeah, but they're both 2.
2n over 2n simplifies to 1. Good. So the absolute value of x minus 9 needs to be less than 1. Center, this is a traditional looking one. The center equals 9. The radius equals 1. So now we have to check our endpoints. Maybe I should write the endpoint test here. Endpoint check. Okay, the first endpoint that we're going to check is x equals 9 minus 1 is 8. So let's check that one. We're going to take the series. The series is x minus 9 to the n over 6 plus 2n. We're going to substitute x equals 8. So 8 minus 9 is negative 1 to the n over 6 plus 2n. Analysis. Alternating series. Not alternative. Alternating series. Let's use the Leibniz test.
I'm still calling
Leibniz
it alternating
test.
series test.
Did you just choose a random test?
That's the alternating series test.
Alternating series test.
Okay. The limit as n approaches infinity of 1 over 6 plus 2n equals, oh, how about that is equal to 0.
Is there an absolute value on that? No. On the alternating series test, is there an absolute value? Yeah.
Therefore, converges. Okay, next endpoint is x equals 10. We'll get x minus 9 to the nth power over 6 plus 2n. That's going to turn into 1 over 6 plus 2n. No longer an alternating series. Is it close to polynomial? Yeah, it's close to polynomial. Let's compare it to a p-series.
1 over n.
Okay. So 1 over 6 plus 2n. If I get rid of all the constants, that becomes 1 over n.
Which diverges.
The series 1 over n diverges. So we're going to compare LCT, the limit as n approaches infinity of 1 over 6 plus 2n divided by 1 over n. That's equal to the limit as n approaches infinity of n over 6 plus 2n,
1/2.
1/2.
which is 1/2. Okay. Since this series diverges, this series is going to diverge. Thank you. Okay, so we have our endpoints tested. So for convergence, x must be between 8 and 10.
Technically, yes.
Include 8, do not include 10. Do not include 10.
Why?
Because it's divergent.
I like donuts.
It's good.
On the ratio test, we get to the point where it's like, where you have like taken out all the stuff that doesn't have n in it, and like what's left is the absolute value after the limit as it goes like to infinity. Like, what if you like can't like, what if there's no like, what if the degree of n for like the numerator and the denominator were different? Like how would you solve?
Whoever has more power.
If it was like 6 plus 2n squared over 8 plus 2n, like how would that work?
That'd give you infinity.
Right. And then you would.
That means that the series never doesn't converge. Okay, let's take a look at the next one. That was very satisfying, that one.
Yeah.
Next. Next. We're going to have question 9. Question 9 is a series x minus 3 to the n over the quantity 3n factorial. Okay, major possibility of algebra fail right here.
It's not 3n plus 1, it's 3 times n plus 1.
Okay? Okay, I think we can see this is not geometric, so we can use the ratio test already. Awesome. Limit n goes to infinity. X minus 3 to the n plus 1. Oh boy. 3 n plus 1 factorial. And as this is a power series, you want to force it less than 1. We're going to do that right now. Okay. I think you can see the x minus 3 kind of comes out. There's a canceling of x minus 3 to the n. And then this is peculiar. Okay, so this is 3n factorial over 3n plus 3 factorial. Okay, so we have to simplify that, right?
Yeah.
Okay, numerator is going to stay the same. That's 3n factorial. Then we're going to start with 3n plus 3. Hey, what's the integer before 3n plus 3? 3n plus 2. What's the integer before 3n plus 2? What's the integer before 3n plus 1?
And then factorial.
Just a 3n's factorial. 3n factorials cancel out. We're going to get 1 over this polynomial. Hey, what's this limit?
0.
0, right?
Yeah.
So basically we're saying 0 has got to be less than 1, regardless of what x is, right?
So it's all
Another way you can write that, of course, is x, all real numbers like that. The fancy R.
Can you just do parentheses negative?
You're going to have to be able to recognize all the different notations on the multiple choice.
So is it brackets?
Parentheses.
Oh, yeah. Yeah.
Okay, good. Number 10.
It's only because if you got an actual number, then you would just solve normally. You would divide by -1, so then it would be. But anything times 0. So it ends up representing something. And 0 is always less than 1.
10.
No matter what you multiply.
We got x minus 6
To
to the 2n on top of 16 to the n. Okay, so I don't know if you recognize this, but this is geometric. Okay, and to help you see that, we're going to substitute 0. If I substitute 0, I get 1. If I substitute 1, I get x minus 6 squared on top of 16. If I substitute 2, I get x minus 2 to the 4th power, all over 16 squared. And if I plug in a 3, I get all over 16 to the 3rd power. Very regular. This is a geometric series. Again, please write these terms. Geometric series. Mikhail, I'm talking to you. Please make sure you write all these terms out. First term is 1. Ratio is
x minus 6 squared over 16.
x minus 6 squared over 16. Okay, so for convergence,
The absolute value of that is less than 1.
x minus 6 squared over 16 should be less than 1. Absolute values are not actually necessary since we have a square. X minus 6 squared should be less than 16.
So the absolute value of x minus 6 is less than 1.
I think the square root is square root.
Is less than 4, giving me a center of 6 and a radius of 2, which wasn't always obvious, right?
Radius.
It's 4, yeah, it's 4, it's 4. Do I need to test the endpoints?
No, it's geometric.
Do not test endpoints. Donut. Because geometric series. Okay, so x needs to be between
2 and 10.
2 and 10.
Yay.
Done.
Check. We're just not doing 7. That's all.
Power series. That's not geometric. Non-power series. Pretty much anything. Do you want to see what we did last year for number 7? What did we do last year? What did we do last year? Chapter
Just
9. Here we go. What did we do? Oh, we're jumping around here. Bye-bye. No, that's number 9.
Because everyone has a natural log
10,
and
6, 5, 4. Yeah. Do you want last year's too?
that one, this one. This one. Oh my
Oh, wow.
What is the integral test? What is the integral test? We were never taught the integral test. No.
Huh? Yeah.
What is integral?
What the heck? Mr. Ferreria. Back to the problem.
This is not.
Wow.
So that's not going to be on the test. Because we didn't learn that.
How did you do number 11 then?
Did you actually get your answer? I don't think so. We didn't learn it.
I was here for 7. This always happens to me. No, I mean, it's so hard to do we still need to be responsible for number 7?
We didn't learn the integral test.
What about 11? Can we see
I would also be super happy driving like a 1988 Honda.
Let's see what the price is.
I know, but it's like
Always do one.
Great. P.S.
I used for like a spider.
P.S. We did not learn this.
It's like the I like it.
Okay. Thank you, Mr. Ferreria.
What is recurrent? Okay.
We're not responsible for the integral test, and we're not responsible for number 7.
Where's your logical brain? Where's your logical brain?
I just wanted to make sure.
But it's like it also has
Oh, yeah.
with like